Assalamualaikum. In this video we are using a cache simulator. It's a processor cache simulator for the MIPS instruction set architecture. Basically this program is run from the command line and requires Python 3.4 plus to run. It executes the program and runs the simulation and print its ASCII table containing the details for each supplied word address as well as the final contents of the cache, as shown in this figure. First we have to install the cache simulator through the terminal. Before installing the cache simulator, we have to check the requirements to run the cache simulator. Firstly, it requires Python 3.4 plus version, and the second one is the requirement that is given in the folder. To check these requirements are fulfilled or not, we have to check the list. Now we have to tally the requirement from the given list. If the requirements are fulfilled, we have to install the cache simulator using the command pip cache install cache simulator. We are using pip3 to install cache simulator. After the successful installation of the cache simulator, we are running the simulation for the three configurations: direct map, fully associative and two-way set associative. First we have to run the direct map. This is the command to simulate the cache simulator. The first one is the cache size. Basically, it is the size of the cache in words. The next one is the number blocks per set. It represents the program internally represents all cache schemes using a set associative cache. A value of 1 in the number blocks per set represents the direct map cache, and the value other than 1 implies either a set associative or fully associative. The next one is the number words per block. It is the number of words to store each block in the cache, and the default value is 1. Word address. One or more word addresses are separated by the spaces, where each word address is a base 10 positive integer. Now we run this command for the direct map cache for the 10 memory addresses. we place the cache size 840. Number blocks per set is 1 for the direct map. Basically, direct map is a block within a given address which can only be placed in a single location in the cache. Now first we test the first sequence while giving 10 memory addresses. It simulates and provides 2 hits and all the miss for the direct map. Now we try another sequence. It gives 2 hits and all the miss. We try another sequence with 10 memory addresses. It gives all the miss. Now we try another sequence. It also gives all the miss. Now we try another sequence with 10 memory addresses. It gives all the miss and 2 hits. Now we try another sequence. It gives all the miss and one hit. Now we try another sequence for the 10 memory addresses. It gives all the miss and one hit. We try another sequence for 10 memory addresses. It gives all the miss and 3 hits. Now we try another sequence. It gives 3 hits and all the miss. Now we try another sequence. It gives 4 hits and all miss. Now we try another sequence. It gives all the hits and 2 miss. We try another sequence. It gives all the hits and 2 miss. We try another sequence. It gives all the hits and 1 miss. We try another sequence. It gave 5 hits and 5 miss. Now we try another sequence. It gives all the hits and 2 miss. We try another sequence with 10 memory addresses. It shows all the hits and 1 miss. Now we generate sequences for the fully associative. Fully associative basically is a cache that permits data to be stored in any cache block instead of forcing each memory address into one particular block. For the set associative, fully associative, we have placed numbers of blocks per set is equal to 4, and we generate the 10 memory addresses sequence and simulate it. We got 2 miss and all the hits. Now we generate another sequence for the fully associative. It gives all the miss and 1 hit. Now we generate another sequence with the 10 memory addresses. We get all the miss and 3 hits. We generate another sequence with the 10 memory addresses. We get 3 hits and all the miss. Now we generate another sequence with 10 memory address. We try another sequence. We get 3 miss and all the hits. Now we generate another sequence. We get 5 miss and 5 hits for the fully associative. Five hits and 5 miss. Now we generate another sequence. It generates all the miss and 2 hits. Now we try another sequence. Now we try another sequence. It generates all the miss for the fully associative. Now we try another sequence. The memory addresses to generate another sequence are it generates all the hits and 2 miss. Now we try another sequence. It generates all the hits and 2 miss. Now we try another sequence. It generates all hits and 1 miss. Now let's move to two-way set associative. Basically, set associative is a cache in which we divide it into the group of blocks called set. Each memory address maps to exactly one set in the cache, but data may be placed in any block within that set. Two-way associativity means 4 sets and 2 blocks each. For the two-way set associative, we place number of blocks per set is equal to 2 and we test the first sequence with 10 memory address. It shows all the hits and 2 miss. It shows all the hits and 1 miss. Now let's move to try another sequence with 10 memory addresses. It shows all the miss and 1 hit. Now we try another sequence. It also shows all the miss and one hit. Now we try another sequence with 10 memory address. It shows all the miss and one hit. Now we try another sequence. It also shows all the miss and one hit. Let's try another sequence. It shows 5 miss and 5 hits. Now let's try another sequence. It shows all the miss and 3 hits. Now let's try another sequence. It shows all the hits and 4 miss. Let's try another sequence. It shows 6 miss and all hits. Let's try another sequence. It shows all the miss. Thank you.